Hi, this is Chapter 11, Correlational Designs, and I'm Brenda Schmidt.
I'm Kendra Simon.
Mila Nicholas.
And this is our presentation.
We would like to acknowledge that the University of Regina is situated on Treaty 4 lands with a presence in Treaty 6. These are the territories of the Nehiyawak and Anishinaapic, Dakota, Lakota, and Nakota, and the homeland of the Métis-Michif Nation. Today, these lands continue to be shared territory of many diverse peoples from near and far.
Our agenda today is going to be definitions of correlational research, two types of correlational designs, key characteristics of correlational designs, potential ethical issues in conducting correlational research, steps in conducting a correlational study, and list the criteria for evaluating a correlational study.
So what is a correlation? A correlation is a statistical test to determine the tendency or pattern for two or more variables or two sets of data to vary consistently. In order to define correlational design, knowing what a correlation is helps us understand what is happening in correlational design. As we look further into correlational design, remembering that the meaning of correlation is to look for a connection or relationship between two or more variables is key. So what is correlational research? Correlational research allows researchers to investigate the relationship between two or more variables or sets of scores. Correlational research differs from other types of research designs because it does not attempt to change or manipulate variables, but instead seeks to see if the variables relate to one another. This type of research allows one to predict the outcome, examine the correlation of scores, and look for validity. There is no experiment going on in correlational research, just the observation and measurement of seeing if the variables have a relationship to each other. For example, a researcher may look at the correlation between parental engagement and graduation rates. So correlational research has developed over time. And over the last few centuries, as statisticians learn and develop more sophisticated methods to interpret test scores, a well-known biometrician, Carl Pearson, paved the way in the 19th century with his well-known correlation formula that is still utilized today. Others, such as Ewell, Pearson's student, developed stronger solutions to look at more than two variables to determine a correlation. Spearman pioneered the correlation matrix, while others in the 20th century continued to refine and strengthen the correlation process. Today's researchers use computers that allow them to examine several variables using advanced correlational techniques to analyze the data. Correlational designs is quantitative research due to the variety of developed applications and procedures to measure correlations. Two of the primary types of designs are explanatory and prediction. So in explanatory design, the researchers mention their variables in the purpose statement, the research questions, or on tables reporting the statistical procedures. Researchers are not concerned with the past or future performance of the participants. The researcher collects scores from only one group and does not divide the group into categories. In contrast to experimental research, all levels of information are used on a continuum of scores from 10 to 90. Within the research, the investigator will mention how many scores were collected from participants. The researcher also mentions strengths and limitation of the data. The researcher can only use statistical control until altering conditions and variables in experimental research. The prediction design, on the other hand, is where researchers are looking to see how variables relate. The purpose of prediction design is to identify variables that will predict the outcome. The outcome being predicted is called the criterion variable. The word prediction may also be used in the purpose statement or research questions. For example, the predictors, which are factors of student success, could be collected early on, and the criterion variable could be measured later to determine if the factors impacted the criterion variable of year-end test scores. Their intent, known as a prediction of the research, is stated in the purpose statement or research questions.
The key characteristics of correlational designs are display of scores, which is shown in scatter plots and matrices, associations between scores, and multiple variable analysis. Okay, for display of scores, this one here is a scatter plot, and scatter plots are used when you have two variables. It helps provide a visual of the scores to identify the type of association between the scores, and it also provides information about the form of association. So is it linear or curvilinear? So if you look at the example here, 11.1, we have a linear graph that's comparing depression scores versus the hours of internet use per week. And you can see that they have the linear line going through, and they're comparing the number of hours per week versus the depression scores, which is your Y. And so if the around the 15 on the X value of hours per week, you can go all the way up to see that your depression score is around like the 45-ish mark there. So this is just how a scatter plot would work. A correlation matrix presents a visual display of the correlation coefficients for all variables in the study. In this display, we list all the variables on both a horizontal row and a vertical column in the table. Correlational researchers present correlation coefficients in a matrix in published research reports. Here's an example that reports coefficients for the correlation of 6 variables in a study of variables associated with school satisfaction among middle school students. Notice that all the 6 variables are listed in both the horizontal rows and vertical columns. To simplify the table, the authors assigned numbers to the variables and included only the numbers in the column heading. Coefficients ranging between negative 0.33 and positive 0.65 are reported in cells in the table. We fill only the lower half of the cells because the half of the cells above the diagonal would simply repeat the same information. Finally, the asterisks indicate whether the coefficient statistics are statistically significantly correlated at the p less than 0.05 and p less than 0.01 levels. Now we have the association between scores, and these are evaluated by direction of association, form of association, and the degree and strength of association. For associations between scores, we have direction and form. So direction is, we have positive correlation, points move in the same direction. So when X increases, Y increases. And so the example that we looked at, the scatter plot, that would be an example of positive correlation. Negative correlation points move in opposite directions. So when X increases, Y decreases. And if your scores on one variable do not relate in any pattern or on the other variable, then there are no linear associations. And these usually result in a kind of a circular motion. Your form, we have the linear relation, which is our straight line, and this can be positive or negative. We have a curvilinear, which is a U-shaped, and we have a no correlation, which is a non-linear relationship, and variables are independent of each other. So your two variables are not related at all. So if we look at this graph here, this is just an example of our positive linear, negative linear, no correlation, and our curvilinear relations. Correlational researchers interpret the magnitude and direction of the correlations, with numbers indicating strength and valence signs indicating a direction of +1 to a -1. The statistic provides a measure of the magnitude of the relationship between the two variables. Although the correlation measures the degree of the relationship, many researchers prefer to square the correlation and use the resulting value to measure the strength of the relationship. In this procedure, researchers calculate the coefficient of determination, which assesses the proportion of variability in one variable that can be determined or explained by a second variable. For example, if you obtain R equals +0.7 Squaring this value leads to R squared equals 0.49 or 49%. This means that almost half, 49% of the variability in Y can be determined or explained by X. For the multiple variable analysis, we have partial correlations, multiple regression, and meta-analysis. Okay, so for partial correlations, they're used to determine the amount of variance that an intervening variable explains in both the independent and dependent variables. So if you look at this figure here, 11.3, we have a bivariant correlation on the left-hand side. There's only two variables on here. So we have our independent variable, which is time on task, and a dependent variable, which is achievement. You can see in the middle where they intersect, we have an R squared of 0.5, which is a shared variance. A partial correlation is when you have a third variable intersecting with the first independent and dependent variables. So here you can now see that time on task, achievement, and motivation have now all intertwined. And so now the partial correlation also is interfering with how the dependent and independent react to each other. So now the R squared has gone down to 0.35 squared. Okay, so for the regression line, it is a best fit for all points on the scores of the graph. And so this, what we see is the impact the multiple variables have on an outcome. And we use this calculated with Y, which is your predicted equals BX plus A. So if we look at this chart on this page here, this is in relation to the very first graph that I showed with how hours of internet use affects depression. So Y equals your predicted score on the depression, and X equals the actual score on number of hours of internet use, and B equals the slope of the regression line called the unstandardized regression coefficient, and A equals the intercept or a constant. The value of the value of predicted Y depression on a score when X equals 0. So this also kind of is very similar to if you think of slope calculation in math, like Y equals MX plus B, they just have some of the letters in like different letters. So we would expect an individual who uses the internet 14 hours per week to have a depression score of 41. This score can be estimated by drawing a vertical line from the score of the x-axis variable up to the regression line and over to the y-axis variable, and alternating using the regression formula. So if A equals 6 and B equals 2.5 and X equals 14, then Y predicted equals 2.5 times 14 plus 6, which then gives us the Y variable of 41. A regression table shows the overall amount of variance explained in a dependent variable by all independent variables, called R squared. It also shows the regression weight, the amount of contribution of each variable controlling the variance of all other variables, called beta for each variable. In this table, we see 4 predictor variables of student learning. The coefficients in the right column are the beta weights for each independent variable. A beta weight is a coefficient indicating the magnitude of prediction for a variable after removing the effects of all other predictors. The coefficient of a beta weight identifies the strength of the relationship of a predictor variable of the outcomes and enables a researcher to compare, in data with normal distribution, the strength of one predictor variable with the strength of the other predictors. A beta weight is reported in standardized form. A z-score standardizes the measures so that all variables can be compared, and it is interpreted like a Pearson R with the value typically from +1 to -1. As seen in this graph 11.2, the predictor prior achievement explained the most variance, followed by motivation. Below the table, we see the correlation of combination of variables, which is the multiple correlation design by R of 0.38, and the proportion of variability explained in the dependent variables by all of the predictors, R squared, of 0.14. Meta-analysis. In another extension of correlation research, authors integrate the findings of many primary sources research studies in a meta-analysis by evaluating the results of individual studies and deriving an overall numeric index of the magnitude of results. The intent of this research is to summarize the results of many studies. The process for conducting a meta-analysis follows systematic steps. The researcher locates studies on a single topic and notes the results for all of the studies. Then the researcher calculates an overall result for all of the studies and reports this information. By using this process, the investigator synthesizes the literature, providing a secondary source of primary research reports. Ethical issues conducting correlational research. It is unethical to not have measures appropriate controls. So for example, age, gender, race, or to omit controls. So instead, use a conceptual model to help guide the selection of variables for measurement. Stating found cause and effect, or even probable cause and effect, when results only show patterns of relationship. Failure to analyze and report effect sizes in addition to null hypothesis significance testing, and plagiarizing results or words, fail to report contradictory findings, publish the same evidence many times, and omitting negative findings and alternate explanations. So good scholarship work suggests a willingness to share data, publish one's work, and not letting research reports sit unused.
There are 6 steps in conducting a correlational study. 1, you must determine if a correlational study addresses the research problem. 2, you need to identify the individuals to study. 3, you need to identify 2 or more measures for each individual in the study. 4, you need to collect data and monitor potential threats. 5, you need to be able to analyze the data and represent the results. And 6, you need to be able to interpret the results. The next 2 slides will cover this. Before starting a correlational study, you need to determine if a correlational research addresses your research problem. You need to ask yourself if you are looking to see if 2 variables are connected in some way, or are you looking to explain relationships between variables? The second step is to look for individuals, as a correlational study is comparing participants. You need to make sure you have an adequate size, and it is actually recommended that you have more than 30 participants and that these participants are randomly selected. The next step is to identify 2 or more measurements for your study. Usually, this is done during a literature review where you will look at what other researchers and how they created their measurements and inventories. These inventories should have proven validity and reliability. You may also need to obtain permission from the publishers and researchers to use their instruments. So this is actually when you figure out how you will be coding the participant answers. The fourth step in conducting a correlational research is collecting the data from your participants and coding them. Because you are comparing variables, there needs to be at least 2 sets of data from the participants. Usually, this is shown in a table. The next step is analyzing the data. You will be looking for patterns of responses and using statistical procedures to determine the strength of the relationships as well as its direction. Earlier in the presentation, Brenda mentioned the use of scatter plots, and depending on the scatter plot, it will tell you if it is positive, negative, if there's no correlation, is it curvilinear? Is there a partial correlation? And is there a correlational coefficient? The last step is to interpret the results. This means discussing the direction of the result. This also means creating a visual for your readers, like a regression table or a matrix table. Importantly, did it answer your research problem? So now we're going to go and look at the criteria for evaluating a correlational study. So first things first is that we need to make sure that we have an adequate sample size. So having 30 participants or more is better. The bigger, the better. We need to be able to go and display the results in a table or a graph. So having a correlational matrix showing some of the scatter plots is important. Making sure that the statistical test that is chosen is measurable and it's based on a reliable and valid inventory or measurement, and interpretation and direction and magnitude of association among variables that we can go and assess the strength of the relationship and if it indicates a good prediction. We also need to make sure that the assessment is made about the magnitude of the association based on coefficient of determination. So this means the p-values, the effect size, and confidence intervals in the reporting. The correlational analysis are provided. We need to be able to identify the predictor and criterion variables, but also have a visual model. So it shows how the variables are correlated with each other. So now we are actually going to go and look at 3 examples of a correlational research.
Okay, so for example number 1 for a correlational study, this one here is the stakeholder support of the implementation of Indigenous Peoples Education Program. And so the Indigenous Peoples Education Program is the Department of Education's response to the right of Indigenous people to basic education that is responsive to their context, respects of their identities, and promotes the value of their Indigenous knowledge, skills, and other aspects of their cultural heritage. So this study here is shows the relationship. So we're going to see a correlation matrix, and it's going to show the relationship between the stakeholder support, which is going to be on the left-hand side, in a column, and we have capacity building, indigenized teaching strategies, learning material, and professional development. And so again, this is showing the relationship between the stakeholder support with the implementation of the Indigenous Peoples Program, which then going across the correlation matrix in the rows would be curriculum, teaching and learning process, instructional design, and monitoring. So the research question was to find out whether the support of stakeholders, and for this specific survey, stakeholders are those associated with the welfare and success of a student and its schools. So it's to find out whether the support of stakeholders in the implementation of the Indigenous Peoples Education Program can be an instrument in creating conducive conditions for improvement of schools. So the methods was a quantitative research study, particularly descriptive correlational, and they used a self-made instrument. They did ask 75 people or respondents to respond. However, the number of participants is going to be 31. And this study was conducted in Kittapawan City Division for the school year of 2020-2021. And again, this was a study made use of quantitative research design, particularly descriptive correlation. So here when we look at the correlation matrix, 2 points to take note of are the bolded points with the asterisks, where learning material development and instructional design meet, and they have a significance of 0.388. And then the personal growth in PD with the monitoring and evaluation, which is 0.664. So those are just showing you that they're, the correlation is significant between those two. So the results revealed that learning material development was significantly correlated with instructional design, and where the Pearson R was at 0.388 and the probability was at 0.04, and personal growth and professional development of teachers was significantly related with monitoring and evaluation, again with the Pearson R being at 0.664 and the probability being 0. And since the probability value is less than the set of 5% level of significance, the stated hypothesis is rejected. So the results imply that the stakeholder support on learning material development and personal growth and professional development of teachers enhances the instructional design and monitoring and evaluation of the Indigenous Peoples Education Program. This means that more learning materials are being developed, and the better will be the instructional design of the Indigenous Peoples Education curriculum. In the same way, if teachers' personal growth and professional development is highly developed, they can better assist the monitoring and evaluation of the Indigenous Peoples Education Program.
All right, this example is a correlational study by Sabin, and it sought to explore the relationships between teacher morale, student engagement, and student achievement in regards to reading in 4th and 5th grade classrooms in North Carolina. This study used literature surrounding the 3 variables to see a need for further research. 3 research questions came from the literature to form the basis of this correlational study. What is teacher morale of 4th and 5th grade teachers given the current educational climate as measured by a portion of the Teacher Working Conditions Survey? What is the relationship between teacher morale and the level of student engagement in these elementary classrooms? And what is the relationship between teacher morale and student achievement as measured by growth on the North Carolina end of grade test? So participants in this study were 26 4th and 5th grade teachers from 3 schools with low socioeconomic status. Data collection took place over 3 phases using different types of tools and measurements. So in phase 1, the teachers were given the surveys when initially meeting the researcher. A portion of the North Carolina Teacher Working Conditions Survey was administered to measure teacher morale. During phase 2, over 150 observations on student engagement were analyzed using the Active Learning Inventory tool by Van Amberg et al. In phase 3, the state end of grade tests given to all 4th and 5th grade students were collected. The data was then analyzed. The teacher morale survey was given a composite score among the 5 areas that were looked at. The Active Learning tool categorized engagement in the classroom using a 3-point value: low equaling number 1, moderate equaling number 2, and high equaling number 3. Student achievement was the 3rd variable measured to determine growth. Data was plotted on scatter plots, a correlation coefficient matrix, and tables. With the data gathered from research, there was not a significant correlation between any of the 3 variables. The researcher found this surprising due to the literature gathered before conducting the study. However, one significant finding from the study indicated that when the number of adults in a classroom increased, so did the student engagement, with the correlation of 0.195, significant at the 0.05 level. A few limitations of this study is that I found was the participant size was very small for a quantitative study. A better tool needs to be utilized when measuring student engagement, because the tool did not gauge a student's emotional engagement, which is very important to fully seeing a student's overall level of engagement. Finally, a larger demographic region to collect data from would increase the strength and validity of this study and perhaps determine stronger correlations.
So the third example is a research conducted by Birgit Schmitz and Katja Henke. The research aims to identify the online instructional design elements that encourage active student engagement and students' perceived usefulness. The study looked at elements that created or fostered engaging student-to-student and instructor-to-student learning. The two research questions they had was one, to identify instructional design elements of online learning environments that encourage active student engagement. And the second question is to define the criteria for online classes that influence students' perceived usefulness and students' perceived learning. The researchers applied a bivariate correlational research design. The research had a great sample size of 127 participants, which you could see in Table 1. The researchers also looked at previous inventories in creating their scales for measurement. They actually used the student evaluation of online effectiveness and the university student engagement inventory in helping them create their measurements. The researchers saw 4 distinct factors for assessing online teaching effectiveness, and these are student-faculty interaction, cooperation among students, time on task, and active learning. The research wanted to see if the 4 factors has any relationship that assesses academic engagement, which are behavioral engagement, emotional engagement, and cognitive engagement. But also they wanted to see how those 4 also correlates with perceived learning and perceived usefulness by students. The research results showed a strong correlation between emotional engagement, EE, and time on task, TT, which is a student's perception of course efficiency and assignment difficulty. They also found another strong correlation between emotional engagement, EE, and active learning, AL. According to the research, emotional engagement influences how students feel in relationship to the learning process and class activities. Students are motivated by online classes that are realistic and interactive, allowing them to bring in their personal experiences and existing knowledge. So technology should support learners' task engagement and task completion. Another strong relationship is time on task, TT, and student-faculty interaction, SFI. So this means that a lot of students actually go to their instructors for help and guidance in their learning. However, the research also found that there is a weak correlation between cooperation among students, CAS variable, with behavioral engagement, BE. Students really don't like group work on or collaborating with their peers. So the results of this research shows that online design elements must assist and motivate learners' efforts towards efficiency, which is the TT. So technology can make a positive difference in the teaching and learning environment for both students and lecturers. I thought this was a great correlational research design. It has the 7 criteria of a successful one. They had random and adequate sample size, sampling 127 people. The correlational research design did answer their research questions, and they presented their findings with a matrix and tables showing the coefficients and variable relationships. The researchers were able to make predictions and recommendations in improving online course design elements as well.
And now let's have fun and play Kahoot. As you guys can see, there is a link right there to go and enter. And here you can go and enter a pin and see what you learned from our presentation.
Thanks everyone for watching our seminar on correlational design. We hope that you learned a little bit more about what correlational design is and how you would go about conducting a study. We did recognize that it is a complex research design method and requires a lot of steps and pieces that need to be put together before it can be done well. So thanks for joining us, and we hope you have a great day. Bye.